Hello guys, today I want to show you all you need to know about the difference between Java ArrayList and LinkedList. Let's test some operations on them and then compare them. Okay, let's go to the code. Let's start with ArrayList. All I want to show you is how much time it takes to insert into the list, to access an element, and other operations like inserting to the element and to the left, to the right, and compare them. So this is all about these operations. So let's start an array list of integer. Let's say array list, new array list. What I'm going to do is testing to insert to the right. We want to know how much time it takes to insert to the right of the array list or to the right of the linked list, and we want to compare them to see which one is really faster. It's very important when you code, especially when you go to the interview. It's very important to know that which operation, which data structure is better for which operation. So let's insert to the right, to the end of it. Okay, I will say long t1 equals system dot current time in millis, a loop. I want to add 1 million records to the list. And ArrayList dot add I. In this case, in this line, we are adding to the right of the array list, and we are adding 1 million elements to that list. So let's get T2 system dot current time in millis, and let's print add to the right of array list T2 minus T1, the difference. Okay, this is for array list. Now let's check the linked list. We want to know which one is really faster. So let's start another one, linked list. This is of integer, linked list, linked list. And I copy this T1 from here. I copy this loop, but this time instead of array list we want to add to the linked list. So I copy the linked list here, and I have T2. I copy the T2. I don't want to write all of them here. This T2, and then at the end I want to print the time to the right of linked list. Okay, let's run it and see what happens. Which one do you think is faster, array list or linked list? My assumption was at the beginning was linked list should be faster, because in array list, when you reach to the end of the array list, it needs to create a bigger array list and then copy all of them to the list and then add to that. And once it is completed, then again another bigger list and then copy all of them to the bigger list. But in linked list, it only needs to add a new element, a node, and add it to the end of the linked list. I thought this one should be faster, but let's look at this. Something interesting is happening now. Look at here, the array list is much faster than the linked list. So the question is why it is much faster. It's 38 milliseconds in array list and 240 milliseconds. So 6 times, 7 times faster is the array list. So the reason for that is because in the linked list there is an overhead of finding a spot in the memory, getting that memory, creating 2 pointers, one from the end of the list to the new memory, point and one from this new node to the previous one. So this overhead is a lot. So when you do it a million times, it causes this overhead, which you can see here, which is very interesting. It's very important to see how this works and the difference. So anytime that you want to add to the end of your list, go with ArrayList because it's much faster. Now, how about accessing an element? Which one is faster? Let's have a look. So let's say access an element. Okay, T1 system.current time in millis. And for example, let's get from ArrayList that get the element at 500,000 index of 500,000, and look at this. And print out access element of ArrayList T2 minus T1. Okay, this is for ArrayList. Now let's do the same thing for LinkedList. So instead of ArrayList, let's have a LinkedList and copy these two lines. Access element of LinkedList. Let's have a look. Which one do you think is faster? When you access an element, well, definitely I think ArrayList is faster, because for ArrayList, when you give a pointer index, it's one block of code, and it can easily access this one without going through the list. It doesn't need to traverse the list. It knows where the index is and just goes to the index. For example, it adds 500,000 to the beginning of the the address of the beginning element, and it finds it. But for linked list, it needs to traverse, start from beginning and go one by one to the end. So definitely the ArrayList is faster. But do we have a feeling of how much faster? Is it a big difference? Let's have a look. So ArrayList is 0, linked list is 9 milliseconds. So although that the linked list needs to traverse, but 500,000 elements, traversing 500,000 elements is just 9 milliseconds. So if your system works with 500,000, 1 million record, doesn't matter. The difference is not that much. But if you work with a very big list, then definitely go with ArrayList, because ArrayList is 0. Beautiful. Now the last thing which is very interesting that I want to talk about is to insert to the left. This is very interesting. Let's create our ArrayList, clear, and T1 is system.current millis, and a small loop less than 1 million to add 1 million record to that. And ArrayList.add, we want to always add to the beginning, so always we want to add to the index of 0. So by doing this, when we say ArrayList, by doing this we are shifting everything in the ArrayList every time one location to the right. Imagine it has 8 elements, we want to add the 0, then we need to push all those 8 elements to right to have one open spot, and then put this element into that. And we need to do that 1 million times. Should be interesting, isn't it? And add to the left of array list. And let's do the same thing for linked list. So the linked list should be clear. We want to make it empty. We have this T1. We have this loop. But here we have linked list. And T2. And at the end, the message. This is for linked list. Okay. So let's see. We definitely know the difference now, but we want to see how much is this difference. We we want to get some feeling of the difference. We know definitely that ArrayList is very slow and linked list is much faster, because in linked list we just need to create one node and update the pointers. That's all. Every time that we need to insert, we create a node and we update pointers, 2 pointers. But in here, in ArrayList, we need to create an element, but we need to push everything in the ArrayList one to the right, to shift to the right one spot. So it should be much harder and take some time. But how much? Let's see the difference in 1 million record. So I run it again. Okay, started. This is adding to the right of array. These are the previous executions of the application. But now look, nothing is happening. Looks like it takes so much time for the array to shift all the elements to the right by 1. Imagine we have 500,000 elements in the array and we want to add 1 element to the left. We need to push all those 500 elements to the right by 1 position, and then we add our element to the left. And then the next one, we need to move all 500,001 element to the right and add 1 element to the left, and then 500,002 element to the right. So it's a huge amount of time. And look at this, although these systems these days are super fast, it is still taking so much time. And to not waste your time, I will pause this video, and once it's finished, I will come back. Okay, look at here, 100 seconds, 100,000 milliseconds to add to the left of array list, but only 186 milliseconds to the linked list. So look how big is this number. So when you work with arrays, if you need to insert to the left of to the beginning of your array or list, never use ArrayList. The performance is horrible. These are the things that I wanted to show you, because I know that there are so many developers, even senior developers, that don't have a good feeling of the difference between these data structures, and they just use one by default, always ArrayList or always LinkedList. But you can see that the difference can be huge. This is really all you need to know when when to use these data structures. If you are finding this video helpful or interesting, it's a good time to subscribe to my channel. I'm going to show you lots of amazing stuff here in this channel. Thank you for watching, and see you later.